Okay, everybody, welcome to Lecture 6. So we talked about a little bit about the perspectives within psychology, so now we're going to talk about studying human behavior. So this section is going to rely mostly on talking about research and research methods and all of that. And again, I took most of the information from the textbook, The Psychology and Perspectives, from Tavris and Wade. Of course, I did have to go get some extra sources for some of the other things because, again, I feel like, even though this is supposed to be a 101 course, I think it's important to, dive as deep into the information as possible so that way you can kind of get all kinds of different, not just, different sources on things, but, to expand on the material enough that, it generates an interest. So let's get started. So we're going to talk about what makes psychological research scientific. Because, they talk about a story in the textbook, the Tavris and Wade textbook, about facilitated communication for autistic children. So basically what they were trying to do was have these autistic kids kind of learn how to write things, and the facilitator would kind of put them in the general direction so that way you could get kids to communicate. And but of course, anytime that you have something like that happen, you're going to have biases kind of come in. And so what kind of put a stop to that was there was a legal case that involved an autistic girl named Betsy who communicated via facilitator that she had suffered abuse, and because of this she was removed from her family. So a psychological researcher tested her multiple times and found that Betsy could only type what the facilitator saw and not what she saw. So she would type hat if the facilitator said, there's a hat, you need to type this. Whereas if a child saw a cup. And so the child ended up being reunited with their family, and facilitated communication was discontinued. But facilitated communication was considered this great thing that was being pushed forward, because anybody with an autistic child, especially if they're nonverbal, this is a way to kind of get them to communicate. So, and it's not a hypothetical story. This was actually done in the 1990s, and the research findings showed that it was no different than, a medium trying to use a person's hand to guide them on a Ouija board to facilitate communication with a spirit. So if anybody's ever played with a Ouija board, you put your hands on the planchette and ask questions, and supposedly spirits will move the planchette. Well, it's almost like putting your hands on the planchette and letting a medium kind of guide your hand along. And so it's not that you're finding a message from the spirit, you're just finding the message that the medium wants you to find. So that's kind of how it is in principle. So the question is, what makes psychological research scientific? Well, precision, for one. Psychologists, like scientists, launch an investigation because they have a hunch about why a behavior or a problem occurs. These are often based on observations. So, they might observe a behavior, and they might say, well, why does X behavior happen? Does it happen because of Y or Z? So they'll kind of start off with this theory, and they'll form a hypothesis to kind of describe or state the problem. And the hypothesis will then be stated in the form of a question with operational definitions. So like in personality psychology, one could ask, well, are people who tend to be very polite also sensitive to negative emotion? So you might say that anybody that's extremely polite, they don't like conflict, and if they get into a situation that might arise of conflict, they might become either more anxious or depressed, and so they might be more sensitive to, say, negative emotion. Skepticism is something else that makes psychological research scientific, because psychologists, like scientists, we can't accept ideas on blind faith. So we need evidence and data to support those ideas, and that kind of is why when we talked about the hand of psychology, you have the thumb. That's the psychodynamics. So that's the unconscious. So it's not quite empirical. It's mostly theoretical, and it's kind of hard to test. That's one of the reasons why people don't like the implicit associations test, which has a reliability I think of about 0.4, and I don't even think the validity is even that high, and it's one that they use to test for implicit biases and stuff like that, and it's not very reliable. So, we don't accept ideas on blind faith. Evidence and data has to support those ideas. And there's a reliance on empirical evidence. So unlike plays or movies, scientific theories are not just judged by the entertainment value or the palatability. They need to have some serious empirical evidence to allow them to be taken seriously. And the intensity of a conviction that a hypothesis is true has nothing to do with whether it is true or not. It doesn't matter. You could say, well, I believe the sky is red, but empirically the sky is blue. So, that's kind of how that goes. You have to be willing to make risky predictions, and a related principle is the principle of falsifiability. Is that a scientist has to state their hypothesis in a way that can be refuted or disproved. It doesn't mean that it will be disputed, but could be with the appropriate evidence. Non-scientists violate the principle of falsifiability all the time. In the 1980s, there was this whole panic about the presence of a murderous satanic cult that was widespread, and despite the fact that FBI, police, and even research psychologists couldn't find any evidence of it, it was called the Satanic Panic. And it was very prevalent in the 1980s. Dungeons and Dragons, a tabletop role-playing game, was kind of sucked into that. There was, I think I talked about it in the last lecture about, false memories and how there was a bunch of small children that were interviewed, and because they were small children and the way that they were being questioned, they were being led to answer questions, and it basically, the way that the questions were asked, they were led to answer these questions in a false manner, and they said that they had remembered these things, which they didn't. So that's kind of where that's the Satanic Panic. Is it turned into these like satanic rituals and all this? It was very outlandish, and so you could tell these kids were just having this imagination. So there was like archetypal monsters and all the things that we'd find in something like this, and so you got to be able to make risky predictions and then try to test that out. And then there's openness. Scientists and psychologists must be willing to share their sources for their ideas, how they're tested, what the results were, and it has to be detailed so that the experiments can be replicated, and so that the outcomes can either be verified or challenged. And are these standards perfectly lived up to? Of course not. Human beings, we make mistakes. We can put too much trust in anecdote. We can permit financial interest to interfere with findings, or, not fully put the ideas to the test because nobody wants to see a good idea turn out to be false. So one of the things that helps with that is peer review. And peer review is like a research checks and balances through which other researchers and experts kind of review and comment on the experimental data, so that the good ideas with sufficient evidence can be advanced, and the bad ideas with little to no evidence or even fraudulent evidence can be kind of sent to the scrap heap and be done with. Because you want not perfect, but you want sufficient evidence that an idea is valid. We're going to talk about validity and reliability as we go on through the lecture. Psychologists like to gather evidence to support their hypotheses by using different methods. So this is kind of where we get into the different research methods. So descriptive research. There's different methods of this, and these methods are not mutually exclusive. Descriptive methods just allow psychologists to describe and predict behavior and not choose one explanation over the other. So it's not this explanation is perfect for this, or this explanation is perfect for that. There's actually a bit of nuance about it. Sorry about that. So, case studies. They're detailed descriptions of an individual based on careful observation and with formal psychological testing. It'll include information that will provide insight into the individual's behavior. They're often used by clinicians and sometimes by academic researchers, and case studies generalize and abstract psychological principles in ways that statistics cannot. Case studies, unfortunately, about some of the vital information that can be difficult to interpret. They aren't useless by any stretch of the imagination. They give good biological psychologists a good insight into how the brain is organized, and when you're reading a case study about an individual with traumatic brain injury. So somebody from the biological perspective of psychology might look at things and say, okay, we have person X has a brain injury, and these are the observations of behavior that we're seeing, and so they can write that down. So you can make a lot of inferences about their behavior and see like what deviations are from, say, normal behavior in a control group, like a person without a brain injury. So you can kind of make the comparison based on the case study. There's observational studies. This is kind of where a researcher will observe, measure, and record behavior while taking care not to intrude or interfere with the subjects being observed. This kind of comes from anthropology. You've heard of, if anybody here has ever taken an anthropology course or has looked at anthropology lectures, what they call participant observation or field work. It's kind of where you kind of participate a little bit, but it's mostly to observe and record and write things down. This is kind of what an observational study is like, and often it's the first step in a program of research, and the primary purpose of naturalistic observation is to see how people act in their environment normally without deviating due to the observant. So there's not so much of a participant aspect to that like you would see in anthropology. Researchers who do these studies not only rely on they do not rely on memory or impressions during the observation. They have to count, measure, rate the behaviors in a systematic way in order to be sure that you're not what you make sure they're not what you expect or want to see. So the careful record keeping maintains accuracy. Also allows for that check and balances so that others can check your record. So there's a bit of peer review in there. And many of these studies occur within a laboratory setting as well, where there's a bit more control. You can see many people being observed at once, often with the use of a one-way mirror. That's where they can look at themselves in the mirror, and you can kind of see into the mirror and see what they're doing without them seeing you, kind of thing. Especially if, going to a subject's home is kind of inconvenient, you can bring them to the lab. But the one shortcoming of this, especially in the lab, is there's going to be equipment, researchers are going to be present, and that might affect the subject's behavior. Also, these studies, like case studies, they're used to describe behaviors rather than actually explain the behavior. So, again, it's just a descriptive kind of thing. Tests. So, these are also called instruments or assessments. You've probably heard me use the term assessment. I think I use instrument as well as a lot. I don't really use the word test, but they're basically procedures for measuring and evaluating, anything from personality traits, emotional traits, aptitudes, values, interests, and typically they kind of require a participant to answer a series of questions, and the results are scored to give a single numerical score or even sets of scores. One example is the Big Five Aspect Scales that was designed by Dr. Colin D. Young, Dr. Lena Quilty, and Dr. Jordan Peterson. And this is an assessment from 2007. And it measures personality traits within the Big Five and utilizes sets of scores. So you'll have openness has a set of scores, agreeableness, conscientiousness, neuroticism, and extroversion, right? So those are your 5 dimensions of personality. But there's aspects, so it breaks down each of the 5 into 10. So there's sets of scores for openness and intellect within openness to experience, politeness, compassion within agreeableness, industriousness, orderliness is part of conscientiousness, enthusiasm, assertiveness is part of extroversion, of course withdrawal and volatility being part of neuroticism. So you actually have a series of a set of scores that not only outline where you're at within each of the Big Five, but where you're at within each aspect of the Big Five. So you're actually getting 5, and so there's 15 sets of scores. There's 15 scores, so it's a set of 15 scores. You've got 5 overarching ones, and then you have 10 within those 5. And so one of the ways you can tell if a test is good or not is if it's standardized with a uniform procedure for administering and scoring the test. So the one by DeYoung et al. Is on a Likert scale. So you answer the question on a rating between 1 and 5, 5 being most like you, 1 being most unlike you, and then of course, the corresponding 2, 4, and 3 kind of in the middle. So there's a standard uniform procedure for administering and scoring the test, and those who take it need to know exactly how to take the test, and those that score it need to know precisely how to do that, because if there's any error in that, then you're going to cost the test its reliability, and you're going to cost its validity. So if you don't know what you're doing, then you're going to totally just make it not worth anything. So scoring of the instruments are usually done by referring to norms. That's the established standards of performance, and these usually include make sure the test is administered to the intended population, and that it's scored according to what is considered high, low, or average. And so those are your scores. You have high scores, low scores, or average. And then of course there's extremely high or extremely low, depending on what the norms are for that particular assessment. So constructing a test is not as easy as it seems. The test cannot just be questions that interest you. It has to be reliable. So this is one of the big ones, right? So what that means is it has to be able to be administered and then re-administered with very little variance of the outcomes. So if you take an assessment that says you'd be a great engineer and a poor artist, then you retake it and it says you'd be better suited as a journalist and a poor engineer, then its reliability is pretty poor. And so, but if you administer a test to one group and then you give it to the same group again within a month and the results are statistically the same, then it's a reliable instrument that has a test-retest reliability. So it has to have a reliability that's pretty high that makes it useful. And there's different ways you can test the reliability. So there's the test and retest, and then there's also a different format. So you can have items that are similar in format, but they're not consistent, or they're not similar in content. So instead of multiple choice format, like a true or false, you could use true or false instead of multiple choice. And this type of test is like, say, for learning proficiency, like in a classroom. So what you're trying to measure then is, the knowledge gained in that set of class. And so these tests have called alternate forms reliability that supports their usefulness. So it's pretty good to know. Now, for a test also to be useful, it has to be valid. That means that it must measure precisely what it's supposed to measure. So a creativity test isn't valid if it measures like your verbal sophistication. It doesn't work that way. If the items broadly represent the traits in question, then it's said to have content validity. And most tests are also tested for what's called criterion validity, and that's the ability to predict other independent measures or criteria of the trait in question. Now, criticism and reevaluations of psychological tests are what keep them honest and scientifically rigorous, in contrast to the pop psych tests that you frequently find in magazines like Cosmopolitan. They haven't been evaluated for reliability, and so or validity, so it's safe to assume that they're neither valid or reliable. They're just BS tests put in there for your own amusement, but it's not really psychological research. It's, like I said, it's entertainment's pop psych. Surveys. Surveys are questionnaires and interviews that gather information about people by asking them directly about their attitudes and experiences. And so as social scientists, especially if they're worth their salt, they do like surveys because they produce different kinds of data, but unfortunately they're rarely done well. So the biggest hurdle to leap over is getting the representative sample, so a group of subjects related from the population that represent the larger population. So you want to pull a random sample out of a population that's representative of the whole if you're going to do a survey, because then all it is random people, so that kind of hurts its validity and reliability, because then it's just not going to go very well for you. And most people do not know that It's not the sample size that matters. It's its representativeness. So a small but representative sample can produce a very accurate results, and a survey that doesn't use the proper sampling procedures produce questionable results at that. So popular polls and surveys suffer from what's called a volunteer bias. And what that means is that the findings are representative of the volunteers rather than those who didn't. So it's not a representation of the whole. Another problem with surveys is that some people tend to lie, especially if the subject is touchy or controversial. Got into a little bit of a debate about this with a friend of mine where we were talking about a survey over the federal government's satisfaction of handling of the coronavirus. And in the state, most people are satisfied or more satisfied than they thought they would be, or something to that degree. And I said, it's not exactly an empirical survey because of the volunteer bias. And most people that feel the strongest about it one way or the other are going to be the ones that are going to take the survey. And so then the data is going to be skewed toward those opinions. And so it's not representative of the whole. And you have to kind of keep that in mind. So that's kind of why, surveys, you have to be very, very careful about, the data that they collect. Correlational research. In descriptive research, psychologists often want to know if two or more phenomena are related. And if so, how strongly? Well, for example, is there a correlation between the hours someone watches TV and their GPA? And to sort that out, you have to do a correlational study. So correlation is often used as the synonym for relationship. Is there a strong relationship between the two? And so a correlation is a numerical measure of strength of that relationship between the variables. Characteristics that can be measured by numeric scales. Some variables can be manipulated in those studies. So that's where your independent variable, that's the one that gets monkeyed about with and compared to the dependent variable. And so the outcome, that's kind of what that does. And so correlation will always occur between sets of observations. In psychological research, these sets of observations usually come from many individuals and are used to compare groups of people. In the research of IQ, for example, psychologists look for correlations between IQ scores of parents and those of their children. And to do this, researchers will gather scores from a set of parents and from their children. And you can't compute a correlation if you know the IQs of only one parent-child pair, so you need more than one pair of the values to compare. And so then you'll see positive and negative correlations. So a positive correlation shows high values of one variable happen to be associated with high values of another variable, and that the low values of one variable are associated with the low variables of the other variable. So examples are like IQ and school grades show a positive correlations. The higher your IQ, the higher your score grades are going to be. And then there's negative correlation, right? And what that means is the high values of a variable are associated with the low values of the other variable. So like the older the adult, the fewer miles they can run. So there's a negative relationship or a negative correlation there. Now, if there's no relationship between the two variables, then we say they are uncorrelated. Adult shoe size and IQ are obviously unrelated. They're uncorrelated and doesn't help. Or it doesn't. They have no relationship in relation to one another. Sorry. Okay. The statistic used to express a correlation is called a coefficient of correlation. So this number ranges from -1 to +1. So that's a perfect negative and a perfect positive. And if a correlation is, say, 0.8, the variables are strongly related. If the correlation is -8, it shows a strong but negative correlation. Anything near 0 or at 0 indicates there's no association or relationship or correlation at all. And correlational findings are common in psychology. They're often reported in the news, but do beware. Correlations can be misleading. And remember, correlation does not show causation. Just because A predicts B doesn't mean that A causes B. And that's why I have the funny little sign there that says correlation is not causation, but it sure helps. Experimental research. This is actually my favorite type of research. So researchers will gain plenty of information from descriptive studies, but when they want to actually track down the cause of behavior, they have to rely heavily on the experimental method. And an experiment allows a researcher to control the situation being studied. The researcher goes from passive recorder of what's going on to taking an active role in doing something to affect people's behavior and observe what happens. Experiments are ways to actively test hypotheses and to record the results. So in an experiment, you already heard me talk about the independent variable and the dependent variable, the IV and the DV, if you will. So the independent variable is the variable being manipulated, and the dependent variable is what the experimental predicts will be affected by the manipulation of the independent variable. So you can think of it as a condition of, if condition is X, then Y will happen. So experiments often have an experimental condition or comparison, or what they call a control. The control condition is where subjects are treated exactly like the experimental group, except they're not exposed to the treatment. So they're not exposed to any manipulation of the independent variable. Their independent variable is left static. And then, of course, you compare the two. And so the picture that I've posted here is from the Milgram experiments, and this talks about like authority. So you have an experimenter who's in a position of authority. You have the subject who's being, they're trying to predict his behavior. So the dependent variable is the subject administering the shocks. The independent variable is the experimenter urging the participant to keep going. Now there's a fake test subject on the other side of a wall who's going to scream when a light lights up, because that wire there, that doesn't really give a shock like it's supposed to, but when he presses a button or turns the dial, it's supposed to light it up, and they're supposed to scream in relation to the intensity of the light to give the illusion that they're suffering shock. And so what the experimenter is actually trying to test is, if he's urged to keep going and increasing the intensity of the shocks per wrong answer given to the fake test subject, the prediction is that the subject will stop administering shocks after a certain intensity. And of course, because of deference to authority, this subject is actually more than willing to go until he sufficiently believes that he's caused significant bodily injury. So that's the Milgram experiments. It's actually talked a lot about in Philip Zimbardo's book, The Lucifer Effect: How Good People Turn Evil. He talks about the Milgram experiment. Christopher Browning also wrote this book. It's a history book. It's called Ordinary Men, and it's about a German police battalion that goes into Poland. And because of deference to authority, along with other psychological factors, they actually take part in the atrocities that Nazi Germany committed in Poland. Really good. They're really good books, and they kind of talk about the Milgram experiment. They talk about deference to authority and how deference to authority is just one factor that can influence people to do really horrible things. So to get to the two groups in an experimental setting, random assignment is often used to make sure that both groups are in similar age, education, and other characteristics. Sometimes the control group are given a placebo rather than having them refrain from a condition. So if you're testing the hypothesis that cigarettes increase reaction time because of the stimulant in nicotine, you may have the control group have like placebo nicotine or placebo cigarettes, rather than have them refrain from smoking, so that way you can test a nicotine without it and a nicotine, and you might have them do tests that test their reaction time. So that's kind of how that kind of works. It's an example from the book, and I couldn't think of anything better to try to abstract that with. And because expectations can influence the results of the study, subjects should not know whether they are an experimental or a control group. So what happens then is the experiment is said to be a single blind study when the subjects do not know which group they are in. Subjects aren't the only ones who can bring expectations to a study. Researchers can do that too. Many years ago, there was a guy named Robert Rosenthal. He wrote this paper in 1966 about what's called the experimenter effect, which are unintended changes in a subject's behavior due to cues that are inadvertently given by the experimenter, whether it's through body language or facial expressions or anything like that. So, to solve this problem, a double-blind study is done. This is an experimental setup where the researchers have no idea which subjects are in which group, and the subjects, none of the subjects know what group they're in, and the researchers aren't told until the study's concluded and the results are recorded, and then they kind of will go and try to interpret the results. Now, the advantage of experiments is because they allow conclusions about a cause and effect to be made, and they permit researchers to distinguish real effects from placebo effects. In fact, experimental method is the method of choice for psychologists. Due to the experimental method, we've learned that not all antidepressants are miracle drugs. So when you're testing antidepressants or SSRIs on patients with depression, they might give them a placebo, and other people give them the new SSRI and see if you see an improvement in their overall mood and all of that. So this is why they figured out Zoloft doesn't work for everybody. It only works for maybe a select few. And so experiments have their limitations though. Like all kinds of studies, participants are not always representative of the large population. Most volunteers in psychological experiments are college students who differ in many different ways from people who are not in school. Thus, researchers in psychology are now calling for more field research or the careful study of behavior in its natural context. So you're starting to see a little bit of that anthropological influence kind of come back into psychology, or come into psychology. So evaluating the results. So if you're a psychologist who completes a study, a survey, or an experiment, your work actually just now begins. So it's not just about the experiment. And so there's a three-step process for evaluating your results. You need to describe them, assess how reliable, valid, and meaningful they are, and then figure out how you're going to explain them. So let's talk about descriptive statistics and evaluating your results. And there's graphs and charts and all that good stuff. And I'll after I talk about it, I'll undo the picture so that way you can take a look at the whole picture of all the different graphs and stuff. So to summarize the data, people are going to want to know what happened to an experimental group compared to your control group. And such numbers are called descriptive statistics, which are often depicted in graphs and charts. Hence the picture on the right hand of the slide there. And so descriptive statistics are statistical procedures for summarizing data. It's good, and a good way to do that is to calculate your average or your arithmetic mean. And the average is calculated by adding up the set of numbers and then dividing it by the sum of the total of the quantities in the set. For example, if you had 20 people and you gave them a 5-factor model assessment and added up the total scores and say trait agreeableness. So what you would do is you would take all of the total scores in trait agreeableness and divide it by 20, giving you an average score of agreeableness among the 20 subjects. So let's say get 20 subjects, you add up scores in agreeableness across all 20, divide it by 20, and then you get an average score. So you could say the average agreeableness of the group is such percent. So you could say the average is, say, 65%, right? So you could say that the average person is 65% more agreeable than 35% of people. I think, and so that's kind of what you would do. However, one has to be careful about how those averages are interpreted. It's possible that out of 20, maybe 3 or 4 of them are extremely high in agreeableness. So you could think like 85, 90% percentile of trait agreeableness. And so they might be, more agreeable than 16 or 17 other people. On the other hand, you might have 1 or 2 people that are extremely disagreeable, and so they're less agreeable than the other 18 or 19 people in the study. So that doesn't tell us about the variability in the subjects and of trait agreeableness, right? So what I just pointed out to, the extremely high and the extremely low scores in statistics, we call those outliers because they lie outside the distribution, which is the picture there, which is a distribution. And I'll take my little highlighter and I'll show what all that's all about here in a minute. So for that, you need another descriptive statistic, and we call that the standard deviation. And so it's commonly used to measure the variability that indicates the average difference between scores and in a distribution of their mean. And the larger the standard deviation means the more spread out the scores are and the less typical the average or the mean is. Unfortunately, you only hear about the average when data is being reported. In an intellectually dishonest debate, you might hear about the median. So, for example, you always hear about the gender wage gap and about the median earners of all men and the median earnings of all women. And so men tend to make, what is it, 70 cents to the more on the dollar than women do, I think is the argument. But when you actually break it all down into all the different variables, you start to see that gap disappear. So that's kind of dishonest because they're not taking the average. They're taking the median. They're taking the middle number. And so this is so what the median does is it's the middle number, and it separates the upper values from the lower values of a data set. So it's not a true representation of the whole, and that comes straight out of the book. And so, like I said, I'm going to do away with the picture in picture here. I'm going to grab my highlighter because I don't have a... So this is your average, right? This is considered your average in the distribution. And so you might have this here. So this is average. This is average plus 1 standard deviation. So average plus 2 standard deviation. So 1 standard deviation from 34.13 is 13.59. Your second standard deviation is 2.4 or 2.14. 3 standard deviations is 0.13. So that's a heck of a spread between the scores there. So that's what that shows you, the variance between the scores within the distribution. Okay, so bringing that back. Now, I showed you the standard distribution, right? You're going to see that more in psychological studies. Every once in a while, you might get this weird little one. So I figured this would be really good to talk about. And it's a Pareto distribution. And what it is a skewed distribution with heavy, or what they call slowly decaying tails. In example, much of the data is in the tails. And so the Pareto distribution was created by the 19th century Italian economist Vilfredo Pareto. And it's defined by a shape parameter, which is called the slope parameter or Pareto index, and its location parameter x. So it has two main applications. You find it in the model of distribution of incomes and the model of distribution of city populations. And so the Pareto principle is derived from the Pareto distribution. And it's used to illustrate that many things are not distributed evenly, like in a standard deviation. It's originally written to state that 20% of the population holds 80% of the wealth. It can be applied more universally. For example, 1% of the population holds 99% of the wealth. However, it can also be used to model any general situation where situations are not evenly distributed. For example, the top 20% workers might produce 80% of the output. So it's the 80-20 rule. And so in economics, it's called the Matthew principle. It's also called Price's law. And so we're going to talk about the Pareto distribution / Matthew principle here. So the numbers don't have to add up to 100%. There doesn't have to be an actual 80-20 split in the distribution. In fact, you'll rarely come across a distribution of anything that's exactly 80-20. Although many things will come close. The main idea behind the principle is to recognize that a small number of cases produce a large percentage of the effect. Now, the distribution split isn't always unfair, and it doesn't always need fixing. For example, 80% of traffic travels on 20% of the roads. This can be beneficial for maintenance crews who can concentrate on that 20% of roads. It can also be great for residential neighborhoods who benefit from reduced traffic flow. It's also called the Matthew principle in economics, and it's because it's taken from a verse in the Bible, Matthew 25:29. To those who have everything, more will be given, and from those who have nothing, more will be taken. So, and it's actually a way the world works if you think about it, because if you've ever played Monopoly, what happens when you play Monopoly to its logical conclusion? One person ends up with all of the money, right? And so one of the things you hear about, like wealth inequality, is that we need to do something about that because it's a problem, and it is a problem. But it's not a problem that you can just lay at the foot of the capitalist system. It happens in every system, no matter which way you do it. If you were to see inequality happening, say, in a game of Monopoly, because it's a voluntary trading game, you're trading paper money for property and all this in this board game. Well, if you start to see the inequality tend to get out of hand, and let's say you were to stop and redistribute everything evenly, and then you begin the trading game again, one person will end up with all the money. So it's a deeper intractable problem that nobody knows what to do about. And so the only way that you could do away with the Pareto distribution is through heavy-handed bureaucratic interference within a free trading game-like system. And that's not good. They tried that in the Soviet Union and other communist countries, and that led to the absolute catastrophe, and eventually, well, the Soviet Union collapsed. China avoided it because they opened up a more capitalist free market society in some degrees, but they still have like some of the more bureaucratic authoritarian stuff of communism. So they're not really a free country. Their market system's a little bit more freer so that they could accumulate wealth for their country, so that way their communist party didn't absolutely collapse into catastrophe. But it doesn't just lay itself out in economics. The concept is applicable to matters of fame or status. It can also be applied literally to cumulative advantage, not just of economic capital. Because in the beginning, what they call the Matthew effect, I'm just going to sit here so we can read it. They were primarily focused on the inequality in the way scientists were recognized for their work. However, Norman Storer of Columbia University led a new wave of research, and he believed he discovered that the inequality that existed in the social sciences also existed in other institutions. So basically what he was looking at from a research perspective was, why is it that it's always the eminent researchers or the eminent people in the fields end up publishing more work than, say, relatively unknown researchers who might produce better results, better research, or put out more papers. And it goes into like a inequality based on like social influence. So they have, because they're considered eminent scholars, they have more social influence. And so there's an influential inequality in that. And then, of course, we talk about Price's law, and it's a square root law, and it pertains to the relationship between the literature on a subject and the number of authors in a subject area, stating that half the publications come from the square root of all contributors. You could look at it goes back to like, okay, let's say you have 100 employees. The square root of 100 is 10, so 10 employees put out 50% of the work of the other 90. And so you could look at it as if you have 100 papers that are written by 25 authors, 5 authors will have contributed 50 papers. Price's law is related to the Lotka law and has been likened also to the Matthew principle, and it can be modeled using a L-shaped graph with the number of people on the y-axis and the production of resources on the x-axis. And so it follows that Pareto distribution that we just looked at in the last slide. So it's a vicious thing, but it's also kind of part of life. But the good thing about that too is, from a psychological standpoint, is when people are trying to get their lives together, small increments in improvement, they manage to compound and add up over time to where you can have massive improvements in one person's life quality over time. But it also says that the more that you reproduce your moral failings, the worse, the quicker you'll fall off the cliff and into catastrophe and chaos. And so the Matthew principle is really kind of good at looking at, small incremental improvements. And that's what people do. Like if you have a really big aim or goal up here, then you can break it down into smaller sub goals that you can climb up the ladder toward the overall goal by, meeting these small criteria for these smaller goals that lead to this overarching goal up above. And so that's kind of that, once you make an improvement, it increases the chance that you'll make the next improvement. And those improvements will start coming quicker and quicker. So that's kind of part of that Matthew principle. So if inferential statistics. So to find out how impressive the data are, psychologists will also use inferential statistics. They don't describe data, but they allow researchers to make inferences about how statistically meaningful the data is. So like descriptive statistics, inferential stats utilize mathematical formulas. The most common statistic for inferential statistics are significance tests. And they will show how likely the results happen by chance. So by convention, psychologists consider the result to be significant if it would happen by chance in 5 or fewer times out of 100 repetitions. And this is called the power level, the P level. So you can see, I'm going to take my little thing right here. So that is where the 0.05, that's the alpha, right? So that's the power level, because there's a 95% like error margin. So that's what this is. And so anything here, you would reject your null hypothesis. So if your P is lower than that, you reject the hypothesis there. Now, if this area is just shaded in, you'd also reject your hypothesis. So anything that shows that in the normal distribution here in the average, then you don't reject your hypothesis. So the most common convention, it's by convention that psychologists consider the result to be significant if it would happen by chance in, like I said, 5 or fewer out of 100 repetitions. Now the last step is to figure out what the findings mean. Sometimes the best interpretation doesn't necessarily emerge until a hypothesis has been tested in different ways. Now here's an example. When psychologists compare the cognitive ability scores of, say, young people and old people, you'll find that the younger people will always outperform cognitively from older people. So this is considered a cross-sectional study because you're crossing two groups of people. So you're crossing two populations, old and young. However, if you want to look at cognitive ability across the lifespan, you do what's called a longitudinal study, and that's because those same subjects are tested and retested and followed over a certain amount of time. So it's longitudinal because it goes across the length of time. I'm pretty sure you guys knew that, but figured it needed to be restated. Now, sometimes psychologists will agree on the reliability and the meaning of a finding, but not on the ultimate relevance for a theory or practice. Statistical significance alone doesn't provide the answer. So many psychologists now refer to other statistical procedures that will reveal the effect size. That's the amount of variance in the data that the independent variable that you manipulate is accountable for. And another popular statistical technique is called the meta-analysis. So what this does is it combines and analyzes data from many studies, so it's more efficient and it works better than trying to assess like a bunch of separate studies separately. So it lumps them all together and you get a meta-analysis that says, okay, well, all of these people have done this study and they've replicated it, and this is what they've kind of figured out and sorted out through time. Of course, when it comes to research, you have to keep it ethical. And rigorous research methods are at the very heart of science, so it's not surprising that psychologists spend considerable time discussing and debating these procedures. Most universities have their own ethics communities, and that they approve all studies to be sure that they conform to federal regulations. It's like the IRB, it's an internal review board that review all of that. Then the American Psychological Association, which is the APA. There's also an American Psychiatric Association that's also called APA. So anytime you hear me mention APA, it's the American Psychological Association, not the psychiatric one, right? And there's the Association of Psychological Sciences, and they each will have their own ethics codes that each member of those organizations have to follow on top of the federal guidelines, which are, held up by the institution's own internal review board. And so the APA also calls for the respect and dignity of all human subjects, and that people know enough about a study and to be informed enough to decide whether they want to partake in it. And that doctrine is known as informed consent. So when it comes to non-human animals, there are also very strict guidelines. And so, let me see here. So no harm can come to them, obviously. Nobody wants to hurt Fluffy. Nobody wants to hurt Squeaker. Nobody wants to hurt, Fluffy or Rover or Meow Meow. So psychologists will still study non-human animals for many reasons, like if you want to understand cooperation among primates, because humans cooperate and primates we share a common ancestor with. Among other reasons, there could be behavior modifications for pest animals, so that way you don't have to resort to shooting them to keep them away from the crop. You might be able to modify their behavior. What works out for them works out for the farmers and works out for everybody. However, the use of non-human animals also sparks angry disputes among animal rights activists because they want to see all animal studies cease. And, fair enough that they don't want to see, humans use animal subjects because, well, in other areas like biomed, you might have some harm that might come to animals, such as giving rats tumors to try to test different therapeutic modalities for trying to, treat cancer. Cosmetics, they used to use animals as test subjects for cosmetics for a long time without any consideration of what the animal might be going through. So the animal rights activists, they do have an argument. However, they've been known to, vandalize and destroy laboratories, set animals free, and all kinds of other things. So it's not really the best relationship, or at least the best way to handle a problem. And then, of course, there's the idea of the meaning of knowledge. So in psychology, along with other fields, there have been heated exchanges on the very meaning of knowledge itself. So to most psychologists and psychological scientists, the purpose of their work is to map out reality in an objective manner. Because we're trying to figure out, what is the world and how do we act in it and why do we behave the way we do. And so a clear line is assumed that to exist between the scientist on one hand and the phenomenon under study on the other hand. However, recently, and this has come to a head in the last 4 years especially, that many academics are now starting to question the concept of science. And these are wonderful people whom I'm not really big fans of, and they're influenced by a philosophy or school of thought called postmodernism, which holds that detached objectivity is impossible. Any findings are just influenced by a researcher's attitudes, culture, values, status in society, and therefore the findings are nothing more than an ideology. So to them, science is an ideology, biology is an ideology, objective reality is an ideology. It's interpretation all the way down. Interpretation turtles all the way down. And so to the postmodernists, especially where the humanities and the social sciences are concerned, the human being's ideas of reality are socially constructed. And some of these things that you're seeing here in quotations, that's the way they're presented in the textbook. In fact, I include the page number, which I'll take the camera thing that you see me on. So that way, if you have the book, you can look it up. You can see it for yourself. I'm not making this up, because when they say that, the human being's ideas of reality are socially constructed, what their presupposition is that there is no such thing as objective reality. The objective world doesn't exist. It's all interpretation and ideology. Yep, page 67 and 68 of the Tarvis and Wade book. And, You know what's funny is if the postmodernists think that science is an ideology and that biology is an ideology, well, I don't care what they say because they act as if they believe in biology because they're all, most of the postmodern jokers are dead. So I guess they act as if they believe in science and biology because, like I said, they're dead. So, I make the comparison of postmodernism where it says, that there's many different ways to interpret an infinite amount of phenomena, which is true. We can interpret things many, many, many different ways. I think I talked about this with the idea of categorization when we were talking about Immanuel Kant all the way back in the very first lecture where I was talking about the philosophers, where psychology came from, where it stemmed out of philosophy. And so, however, the other tenet of postmodernism is that no interpretation is privileged above any other. So it's all interpretation all the way down, right? So my way of trying to make the most sense that I can, and it's a bit of a reduction to absurdity, really is what it is that you and I, let's say you, and just anybody out here watching this, so if you're a postmodernist and you think it's all interpretation all the way down, you might interpret a train as this abstract thing that can do no harm, and I'm going to act as if interpret that train as something that could possibly do me some physical harm, right? I'm going to look at that train coming down the track and be like, nope, that thing will kill me. So we can act out our presuppositions, and if you are a postmodernist and you interpret the train as something other than something that will kill you, then I challenge you to go stand on a railroad track and see what happens, because I can guarantee you're not going to like the bloody result. And so that's kind of my critique of postmodernism. If you really want to understand postmodernism and a critique of it, highly recommend a book by Dr. Stephen Hicks. It's called Explaining Postmodernism, Skepticism, and Socialism from Rousseau to Foucault. And he talks about, different philosophers that kind of started up the post-structuralism, post-modernist philosophy. So there's like Immanuel Kant, there's Martin Heidegger, there's Kierkegaard, Nietzsche. Nietzsche was considered a postmodern philosopher, even though I think Nietzsche was far more brilliant than that. But I mean, there's an argument to the multiple interpretations part, because you can interpret a multiple amount of phenomena, but some phenomena are definitely hold more valid interpretations than others. Darwin's theory of evolution kind of points that one out. And so that's kind of the critique there. So in psychology, again, the debates with the postmodernists, at least in 2001, were challenging because psychologists have this goal. We want to understand behavioral and mental processes of human beings. I mean, for personality, for example, that's something that I particularly like to study is personality. So the Big Five model, that's the most empirically valid, reliable, and most widely accepted model of personality we have right now. The Myers-Briggs is out, gone. We're all about the Big Five. And so now that they're being told that they have to analyze their own values, their genders, which I think is just absolutely ridiculous. Gender has nothing to do with how you interpret data, for Christ's sake. Culture, places in society, and how that affects the conclusions. I don't know, when you look at a 2 and 2 plus 4, that's what I was taught, and that's what's been taught for longer than I've been around. So obviously my culture or my time in space, my values, and me being a male doesn't exactly have any bearing on whether 2 plus 2 equals 4. Now, some do welcome the challenge. Others kind of react in alarm because the postmodernists have this habit of throwing the baby, which we will call rigorous standards and empirical research, and trying to throw it out with bathwater, which they consider narrow-mindedness and cultural bias. So, you don't want to throw the baby out with the bathwater, or else you're going to whoopsie, as you can see in the photo that I've encased in this. And so hopefully this gives you a better understanding of psychological research and all the different methods we use when we try to, when we formulate hypotheses and try to test them in the realm of behavior, especially with personality psychology. We're looking on, trying to explain behavior from a biopsychosocial lens of, because your temperament is part of your biology, which kind of has an influence on your personality. Psychologically, the way you think and the way you perceive reality and the way you act in the world is based upon your personality and kind of formulates your personality. And it's social because we're interacting with other people, telling each other what we want, what we don't want through either actual verbal interaction or the way that our body language is, and so we adjust our personality in that way too. And I will talk about all this when we get through this course, because the next psychology course that I think I'm going to do is actually do an actual personality psychology class, depending on how this whole thing turns out. So that's the plan going forward. So I'll give you my references here for this lecture. And if there's any comments, concerns, there's the comment section down below. If you like the content that I'm putting out here, there's a subscribe button down here, so hit the subscribe, hit the bell. I try to, be a little bit better about uploading content regularly, but, these PowerPoints kind of take time. I have a podcast on SoundCloud at soundcloud.com/tabletalkspodcast, where I talk about a little bit of everything and anything. I also review books that I read. And some of these lectures actually end up on the podcast as well. So thank you guys for paying attention. Hope you made it through. Like I said, if you have any questions, put them in the comments below, and I do make sure to check those so that I can answer questions accordingly. Thank you guys, and that's that.